So the geometric interpretation of the dot product says that the dot product of vectors v and u is equal to the magnitude of the vector v times the magnitude of the vector u times cosine of the angle between the vectors, which is always going to be an angle between 0 and pi, because no matter which vector direction the vectors point, the closest angle is always going to be between 0, pointing in the same direction, and pi, pointing exactly opposite directions. Okay? So in a very simple case, we can imagine that we had two vectors, one with length 6 and one with length 3, with an angle of 30 degrees between them. Then the dot product of these two vectors, we call these vectors, let's say A and B here. Then the dot product of those two vectors would be the magnitude of A times the magnitude of B times the cosine of the angle between. So we'd have 18 times cosine of 30, square root of 3 over 2. We'd have 9 root 3 as the dot product of these vectors. Now the real power of this formula is that it allows us to find the angle between vectors. So for example, if I had the vectors 1, 3, 2 and the vector 5, 1, 8, it's hard to imagine in three-dimensional space what the angle between those two vectors is going to be. But using the dot product, we can find it. So first thing we need to do is find the dot product using the component form. So if I call these vectors, let's say A and B here, then the dot product of these two vectors will be the product of the x components plus the product of the y components plus product of the z components. So 5 plus 3 plus 16, 8 and 16 is 24. So that's the dot product of my vectors. Now I need to know the magnitude of my two vectors. So the magnitude of the vector A is, right, for this we use the square root of the sum of the squares. So 1 squared plus 3 squared plus 2 squared is square root of 1, 9, 13. Magnitude of the vector B is 25 plus 1 plus 64. So that is square root of 80. Sorry, square root of 90. And so now using that in my dot product formula here, we know that the dot product of 24 is equal to the magnitude of the first vector times the magnitude of the second vector times cosine of the angle between. And so the angle between these vectors would be the inverse cosine of 24, dividing this over, divided by root 13, root 90. Okay? And so the cosine inverse will give me the angle between these vectors.